Hello and welcome to Networking at Scale 2023, our summer edition. Networking at Scale is our conference for network engineers who manage and operate some of the largest networks in the world. My name is Rajiv Krishnamurthy. I'm a director of software engineering at Meta. I work in our data center networking group. Now, I've spent about 20 years of my career in the networking industry, worked on hardware and software solutions, routing and switching technologies. Most recently at Meta, I have been focused on building networking solutions for our AI infrastructure, focused on the endpoint. What does that mean? Basically means I'm building networking software and hardware on our servers. Now, Meta has been building global infrastructure for many years now. This serves our customer base of over 3 billion users worldwide. AI has been an integral part of that journey throughout. Some of our solutions are very popular. On the software side, the PyTorch framework, and most recently for Gen AI, the LLM, LLM2, Llama models have become very, very popular in industry. Similarly, on the hardware side, if you look at our custom silicon and also the AI research supercomputer cluster, they have garnered a lot of interest. Now, networking is a critical part of building scalable AI infrastructure. Gartner recently released a report which says that by 2026, almost 40% of our workloads are going to be AI workloads. So if you are a network engineer, you need to pay close attention to this new finicky customer that's going to be a significant part of the data center traffic. And that's the reason I'm excited to bring this conference to you today, where we are going to do a deep dive into the world of AI networking. We have 6 talks and we have constructed them around 4 themes. The first theme is the workloads themselves. Second is data center design. Then it is operations and finally troubleshooting. So let's talk about the workloads. AI models are growing 1000x every 2 to 3 years. And we've observed this internally at Meta. And I think this seems to be a secular trend based on whatever we're observing in industry too. And that number is difficult to grok. So from a physical perspective, this translates into tens of thousands of GPUs, cluster sizes, which means that they are generating exaflops of compute. This is backed by exabytes of data storage. And from a networking perspective, you're looking at manipulating about terabits per second of data. The workloads themselves, they are finicky. By that, people understand that typical AI HPC workloads have very low latency requirements, and also from a packet perspective, they cannot tolerate losses. What we will do when we talk about the workloads is give you a sense that there is a spectrum here. We have on one end of the spectrum the traditional recommendation models, and on the other end of the spectrum we have our latest workloads, which is the generative AI Llama models. How do these workloads behave? What is the impact and the requirements and constraints that they place from a network perspective? So this will be an interesting talk. Okay, so that's the first dimension. We understood the workloads. We consider them as requirements, and we basically get to our next topic, which is data center design. For data center design, what we have done at Meta is we have taken the approach of building a dedicated network. We call it the backend network for our AI workloads. The technology is RDMA. Now, this is distinct from our network that services our traditional web scale workloads. And for lack of a better term, we call that the front end network. So in this talk, we'll explore why we chose to build a dedicated network, what are the challenges, opportunities, benefits of doing such a design. And most importantly, we'll talk about how we can stamp out many of these solutions so that we can deploy this infrastructure at scale. So great, coming back to our themes. We talked about the workloads, we've got the requirements, took those, built, got the data center design done. Now we have to operate these networks at scale. Again, if you look at the workloads, I talked about them being finicky. From a network perspective, typically the workloads have very low entropy in the sense that you will not see symmetric. You see a lot of symmetric traffic flows. They are also very bursty, cause a lot of congestion. So from an end-to-end network perspective, we have introduced dynamic traffic engineering, which allows us to optimally place the workloads and also utilize the network efficiently. So this is end-to-end perspective. If we zoom in into the host itself, you can think of the host as having some discrete critical components like the NIC, the GPU, the CPU. Each one of them can potentially become a bottleneck. So we'll talk about tuning various parameters to again get an optimal utilization of the network. So again, going back to a theme, we talked about the workloads, got the requirements, we did a data center design, we figured out how to optimally optimize and run the network. Obviously, at this scale, things are going to go wrong. And that's where debugging and monitoring comes in. Now, we've spent a lot of time and built a lot of tools for our front end network, which allows us to monitor and troubleshoot it. Now, we've taken that same rigor to the back end, and we have developed a lot of tools that allow us to troubleshoot the network. The talks that we are going to cover today are basically going to focus on two layers. One is the transport layer from the communications library perspective, and then at the network layer from an RDMA perspective. The interesting thing over here is that we'll be able to show you how we can, looking at it from the workloads perspective, quickly identify where the bottlenecks are, which layer. Is it the workloads problem? Is it the network problem? Is it the communication library problem? And isolate it and troubleshoot it. So with these talks, I hope that you get a comprehensive view of what it takes to build, operate, manage AI networking infrastructure to support these large AI infrastructure deployments. This is a very exciting time to be at Meta. We are building and working on cutting edge AI networking innovations in the service of some of the largest AI infrastructure deployments servicing almost half the world's population. If you would like to learn more, or if you would like to join us, please reach out to either me or any of the speakers on today's talks. We are hiring. Now let's get to the talks. Before that, a couple of reminders. We have 2 live Q&A sessions today. If you would like to ask questions from our panel, please remember to submit your questions in the chat box, and the moderators will make sure that your questions are answered. And second, the videos themselves, they will be available on our At Scale website, the Facebook page, as well as our YouTube page in a day or two. With that, I'll hand it off to Tanuja, who's going to be your MC for the day. Thank you.